You think rare earths are rare. The name says so, and the way the subject gets discussed reinforces it. A scarce strategic resource concentrated in one country running short. That is the picture, and every part of it feels like it should be true. Here is the problem. Rare earth elements are not rare. They are in the ground on every continent. Some of them are more abundant in the Earth's crust than copper. The United States is sitting on something like 1.9 million tons of them. And for years, after mining that ore out of California, it was loaded onto ships and sent to China. Not sold. Sent. To be processed and bought back. Not because anyone was forced to, because the step in the middle is so difficult, so dirty, and so unrewarding that almost nobody else was willing to do it. This file is not about who owns the mines. It is about a chemistry problem that 17 elements create by being almost exactly the same as each other. And about what it costs to separate them, which is roughly 200 steps. This is the RISE Index, where we follow the routes that goods, energy, and power actually travel, and ask what happens at the narrow parts. Last file ended on a promise. A material that is not scarce, mined in a dozen countries, sitting in the ground everywhere, where one country processes about 90% of it. That is the gap this file lives in, between having the rock and having the thing the rock is supposed to become. 3 numbers frame it. 1. There are 17 rare earth elements, and their chemical properties are so similar that separating them was, for a long time, considered one of the hardest routine problems in industrial chemistry. 2. The most common method of separating them, solvent extraction, can require up to 200 stages to isolate a single element to the purity a magnet needs. 3. And this is the one the other two exist to explain. One country holds roughly 90% of global refining capacity. Not 90% of the deposits, 90% of the ability to turn a deposit into something usable. Everything after this is about why that third number has survived 40 years of everybody else, trying very hard to change it. And the answer is not the one that gets shouted. Start by taking the supply chain apart, because almost every version of this story collapses it into one word, and the word hides everything. There are 3 steps between a rock and a magnet. Step 1 is mining. Dig ore out of the ground. This part is genuinely well distributed. The United States does it, Australia does it, Myanmar, Brazil, and others do it. Step 3 is manufacturing. Take purified material and turn it into a high-strength magnet, the component that actually goes inside a motor, a wind turbine, a hard drive, a guided system. Step 2 is separation. Take the ore, which contains many of the 17 elements mixed together, and pull them apart into individual, pure oxides. Mining is widely distributed. Magnet manufacturing is about 90% concentrated in China. And separation, the step in the middle, is somewhere around 90% as well. Now look at what that means, because this is the whole argument. If you have step 1 and not step 2, you do not have a supply chain. You have a quarry. Everything you dig has to go somewhere else to become useful, which means the leverage does not sit with the country that owns the deposit. It sits with the country that owns the middle. And that is why the framing you usually hear gets the situation backwards. The question is almost never who has the rock. The rock is everywhere. The question is, who is willing to run the process that turns it into 17 separate things? And the reason nobody wanted that job is not that it is expensive. Plenty of expensive things get built. It is something about the process itself that most countries spent the 1980s actively legislating against. So why is that process so hard? The answer is genuinely elegant, and it is the reason this file exists. The 17 rare earth elements sit next to each other on the periodic table, and they behave almost identically. They form the same kinds of bonds. They dissolve in the same acids. They travel together through the same geological processes, which is why they end up in the same rock. Chemistry works by exploiting differences. You separate two substances by finding something one does that the other does not. With these elements, the differences are minute. So the industrial solution is not to find a big difference, it is to find a tiny one and then repeat it hundreds of times. That is what solvent extraction is. You mix the dissolved ore with an organic liquid that has a very slight preference for one element over its neighbor, very slight. Then you separate the two liquids and one is now marginally enriched. Then you do it again and again. Separating neodymium from praseodymium, two elements that sit directly beside each other, can take more than 60 equilibrium stages to reach magnet-grade purity. Separating a full ore body into all its useful components can run to 200 stages. Picture what that looks like as a building. It is not a laboratory. It is a hall of tanks, hundreds of them, connected in series, each one performing a nearly imperceptible improvement on the one before it. Running continuously, for years. And picture the work inside it, because the abstraction hides the people. A separation plant does not stop. The chemistry only reaches equilibrium if the cascade keeps running. So somebody is walking that hall at 3 in the morning, reading instrument panels, adjusting flow rates by fractions, watching for the drift that means stage 140 is off. It is not dramatic work. It is closer to tending a very large, very slow, very toxic machine that would take weeks to restart if you let it stop. And the skill involved is the kind that takes years to build and cannot be bought quickly. That last point matters more than the tanks do. You can order steel. You cannot order 20 years of operational experience, and a country that has not run these plants does not have anybody who has run these plants. And now, the part that explains the last 40 years better than any political argument does. Rare earth ore is very often mixed with radioactive material, thorium, sometimes uranium. They travel with the elements you want, and they have to be dealt with. Every one of those 200 stages consumes energy and produces waste. Acidic waste, solvent waste, and low-level radioactive residue that has to go somewhere and stay there. Rare earth refining is among the most environmentally punishing metallurgical processes in the modern economy. That is not an accusation. It is a description of the chemistry. So the question of who refines rare earths was never really a technical question. Any competent industrial chemist knows how solvent extraction works. It has been in textbooks for decades. The real question was always who was willing to host it. And it is worth being precise about that word, because it is doing a lot of work. Hosting this process means accepting acidic tailings, solvent residue, and low-level radioactive material in a specific place, near specific people, for decades. Through the 1980s and 90s, most industrialized countries were tightening exactly the rules that make that difficult, and doing so with broad public support. That was not a mistake. It was the point. So, the capacity moved. Not because anybody schemed for it to move, but because the cost of hosting it went up in one set of countries and did not go up in another. 40 years later, the result of those separate, locally sensible decisions is a single point of concentration. Nobody chose deliberately. Which brings us to a single mine in California and the strangest logistics in this season so far. Mountain Pass is the only operating rare earth mine in the United States. It has been there in one form or another for a long time. American ore on American land in a country with a great deal of chemical engineering expertise. For years, After that ore came out of the ground, the concentrate was loaded onto ships and sent across the Pacific to be separated, because the capacity to do the middle step domestically was not there. Then the separated material was brought back. Sit with the shape of that for a second. A country digs a strategic material out of its own territory, ships it 11,000 kilometers to a strategic competitor, pays that competitor to perform a chemical process, and then buys the result. Nobody planned that. No single decision produced it. It is what happens when a supply chain is optimized step by step over decades by companies each doing the rational thing in front of them. And it is changing. The operator of that mine has been building domestic separation capacity and has stopped sending concentrate to China. That shift is real and it is recent, and this file is recording it as in progress rather than finished. But notice how long it took, and notice what it took. Not a discovery, not a breakthrough, a decision to spend money on tanks and to accept the waste that comes with them. Because here is the thing that separates this choke point from the ones in the earlier files. Suez was geography that a person dug. Malacca was geography nobody can move. Cables were an asset that ages. This one is a choke point made almost entirely of willingness. Which sounds like good news, and is the reason this file ends somewhere less comfortable than the last three did. So let us name the concept, because the season is going to need it again. The middle step. In a chain of 3 stages, control does not sit with whoever holds the input, and it does not sit with whoever sells the output. It sits with whoever is willing to run the ugly process in between. And the middle step has a property that makes it very hard to dislodge. It is unglamorous, capital heavy, environmentally difficult, and it generates no consumer brand. Nobody puts it on a flag. Which is the same shape we found in the last file. A cable repair ship produces nothing until the day it produces everything. A separation plant is the same kind of asset, enormous fixed cost, invisible output, and absolutely essential. So what has the effort to change this actually bought? The honest answer has 2 halves, and only one of them gets reported. The first half is real progress. New separation technologies are being developed specifically to reduce the number of stages required. In 2026, an American company began operating a demonstration separation plant. Note the word demonstration. 10 tons is a pilot, not an industry. It matters, and it is not a solution yet, and both of those are true at once. The second half is the arithmetic. A study out of South Korea projects that non-Chinese supply would meet only about 35 to 40% of magnet demand by 2035. That is a forecast, with all the uncertainty forecasts carry. But it is a useful one, because it puts a shape on the gap. Even with everything currently planned, the majority of demand in the middle of the next decade still routes through the same place. And through 2026, analysts describe the binding constraint plainly. It is not mining, it is processing and refining capacity. Which is the same sentence in different words as the one the entire industry has been saying for a decade. So, who carries this? And it is not who you would guess. Not the buyer of a finished product. A magnet is a small fraction of the cost of a motor, and the motor is a fraction of the cost of a car. Even a large movement in rare earth prices barely registers on a showroom sticker. The exposure sits with anyone building something that cannot be redesigned around the shortage. Consider a mid-sized manufacturer of industrial motors, not a famous company. A supplier, 3 tiers down, that has been making the same product for 20 years. Their design is fixed, their contracts are priced, their customers do not accept a heavier or less efficient motor, and the specific element they need is available from a small number of refiners, in one place at a price they do not set. They cannot mine their way out. They cannot invent their way out on the timescale of a purchase order. What they can do is wait and pay and hold more inventory than they would like, which ties up money they would rather spend elsewhere. Nothing about their engineering is wrong. Nothing about their business is badly run. The variable that decides their year is a chemical process happening on the other side of the world, in a facility they will never see, at a scale nobody in their country was willing to build. That is the middle step, collected from a specific place. So, what is the actual choke point? 3 figures answer it. 1. 17 elements, chemically near identical, which is why separating them can take 200 stages and why 60 of those can go into telling just 2 of them apart. 2. About 90% of refining capacity in one country, which is a fact about industrial policy and waste tolerance rather than about geology. 3. 1.9 million tons of American reserves that the United States could not, until very recently, process at scale. The choke point is not the mine. It is not the deposit. It is a hall full of tanks, doing something repetitive and unpleasant, and the willingness to have that hall somewhere near you. And the reason that hall is where it is has almost nothing to do with the rocks underneath it. And notice what kind of problem that makes it. It is solvable, genuinely solvable, with money and time and an honest conversation about where the waste goes. That is different from every other choke point in this season so far, and it is the most uncomfortable thing in this file. Suez cannot be widened past a point. Malacca cannot be moved. A repair ship takes years to build and nobody wants to fund it. This one could have been fixed at any point in the last 40 years by anybody willing to accept the consequences. It was not fixed because the consequences were the whole point. 4 files in, and the season's pattern is now explicit. A canal, a strait, a fleet, a chemical process, every one of them a narrow part, and not one of them narrow because somebody designed it that way. But every file so far has been about a bottleneck that constrains supply. What happens when a country deliberately builds one and it works? Next file. A country smaller than Switzerland, with almost no farmland by any reasonable standard, that became the 2nd largest agricultural exporter on Earth. Not by having more land, by deciding that land was the wrong thing to compete on. This is the Rise Index. Subscribe and follow where power moves next.